So I think that adds more evidence to the view that legumes could well be a part of the solution where we can grow legumes. And what sort of legumes beyond Leucaena are there out there? We've looked at a few others. Stylo, the red line is Stylo, you know, quite high relative to that Leucaena line, which is the blue one, but nevertheless, the more Stylo you put in there does seem to be a trend, and we need to go and look at this more closely. But the other one, the burgundy bean, didn't really make a difference. And I think what's going on here is some legumes have anti-nutritional factors like tannins, which affect the rumen microbe population, and some legumes don't. So not all legumes are created equal. Better keep moving here. The other thing is, if we can improve the diet through adding energy to it, in other words, taking a grass diet and turning it into more of a sort of a concentrate feed. This is just some data from the lab with molasses, and I mention this because, you know, in an ideal world, the molasses that's produced on our eastern seaboard would actually stay in Australia, and we could feed it to cattle instead of being shipped to the US to be used over there. But again, molasses does seem to have quite an impact on the methane emissions because you're improving diet quality. We've talked about fat. The only point here is it's very dangerous to go above about 3 or 4% fat in the diet, because you tend to have all sorts of other consequences that you really don't want to deal with. I'm going to skip over that one. Well, I'll just say quickly that, again, reiterating, it's a series of different management issues, technology developments. If they are additive, we can see if nothing really happened. You know, we carried on increasing herd numbers, we'll have significant increase in methane emissions over the next 20 odd years. But I think with a mixture of different approaches, we can realistically, I think we should aim for a 50% reduction. I don't think that's out of the realms of possibility. I think we could say that within, you know, 20, 30 years, a 50% reduction in methane emissions from the northern cattle industry is a realistic goal. And that's certainly what we're aiming for. It's always good to have goals. Even if you fall short of them, you still do better than if you don't have a goal anyway. 2 minutes to go. I'll just show you, this is some of this laser work we're doing. Allows us to actually measure these things in the paddock. There's an example of you can see use the laser to show you the laser. This thing is shooting across the paddock and measuring the methane from these animals as they roam around. This shows it again. This thing is set up over there, and then it shoots across, it rotates across the paddock and reflects off these units, which should be fixed there, but we hadn't put them up when I took the photograph. But the beauty is there's about 15, 18 animals here, and because we know with GPS position where they are, we can actually identify individual animal methane emissions in that paddock. Now I know that paddock, it's only a hectare, and the question is, well, I've got you know, 1,000 hectare paddock, how are you going to make it work in there? And what we'd like to do, we haven't done this yet, is big paddock, you've got trees, you've got hills, you've got dips and gullies, you can't really do a laser across that, but what we could do is set it up at the watering point, and then when the animals come into water, put them through an NLIS reader. We know when they're in there, we know how many are in there, we can measure the methane across, you know, say 10% of the herd over 10% of the day, and then at least then that gives a method, and we're desperately short of methods. That's the problem. That's why this has never been done before. It's just so hard to do this stuff. But this then allows us then to get some measure, so we can go out in your paddocks and get a direct measurement. To conclude then, we can't avoid the reality that cattle do emit a lot of methane, about 1.5 tons a year. I think any scheme, to be honest, should account for sinks as well as emissions, and I think you'll hear a lot more about that this afternoon. And science is really what's held things up to this point. It's very hard to measure soil carbon in any sensible way, but there are potential down the road. And lastly, I just put this one together last night, and to try and see it from the viewpoint of people in the city, if you like. You know, they know that an average beef animal produces about 1.5 tons of methane a year. And the average family car produces about 3 tons of CO2 equivalents a year. So, you know, you've got 2 cars, that's 6 tons. But if you're an average Aussie, you eat 35 kilos of beef and 18 kilos of lamb, and if you just take the beef in this one, one individual, from the beef they consume, it's going to equate to about 900 kilograms of CO2 equivalents. So the typical family of 4 or 5, mum and dad and 2 kids, and let's say the kids aren't going to eat as much as mum and dad, but the average family, what they eat in beef is probably about 3 tons of CO2 equivalents, and that's the same as a car. So that's the sort of thinking that's going on out there, and that's what you read in the columns in the Australian and other places, is, oh, well, to solve my problem, I'll just stop eating beef. And that, I think, is a real scary concept, because for a number of reasons, and I think one of them is that, what do you do? What are you guys going to do? So what I think, be on the front foot and let's say, yes, there are things we can do to reduce that methane, because you can be damn sure those cars are going to produce less CO2 emissions 10 years from now. So we really have no choice but to embrace this. There are opportunities, and you know, that's why we're here today, to talk to you about them. So thanks very much. Yeah, I'll stay here. This is a scary bit, so I want a bit of protection.
Okay. Oh, there it is. Got to get a bit closer to my mouth. Thanks very much, Ed. Ed's talked a little bit more about the impacts. He's got some measurements to show there, but like Bob, he finished on the idea of there are things that can be done. Questions now for Ed.
The methane gas, that's what everyone's running around trying to find, isn't it now? All the Galilees Basin and so forth, they're all chasing the methane gas.
Well, you know, methane gas is natural gas. It's used to, you know, it's actually seen as a relative to oil, it's quite a green fossil energy. And it's the same as what we're getting off, you know, cattle emit exactly the same methane gas, yes.
Yeah, well, that's what we're told, it's a green energy. It naturally comes up through the earth, and where it's been blocked from coal, they're now trying to run generators and power sources on it. And how come, if it's such a green energy, that now we're on the other side of the foot, it's around in the...
Yeah, that's a really good question, and I think you can answer it on so many different levels. But I guess, you know, the reason it's an issue is, you know, livestock are produced to produce food. They are therefore classed as something that is on this planet for reasons of humankind. They're anthropogenic. And a byproduct of raising cattle is methane. So methane from cattle is seen to be an anthropogenic, that's a hard word, source of methane. So that's why the CPRS scheme says yes, it should be included. Methane that escapes from the tundra, as the tundra melts, there's a lot of methane tied up in the ice in the tundra. As that melts, that will be emitted, and it will probably swamp the amount of methane coming from cattle. But it's not. This is where I get interested. I'm saying, if global warming is anthropogenic and the release of methane from the tundra is due to global warming, what sort of methane is that vis-a-vis cattle methane? So these arguments, you can go round and round in circles, but at the end of the day, you know, governments around the world are looking at anthropogenic, and our government particularly has come out and said methane would be included. Now, you know, I'm not saying I agree with that or anything, but that's the rationale behind it. And I think you can ask those questions. I think they're valid questions to ask and should be asked.
I was trying to say, there's a lot of humans on the earth. What sort of gas do we produce? Obviously.
Yeah, well, that's you know, apparently only some humans produce methane. I think it's about 10%. I think I've heard. Could be wrong on that figure, but some humans do not emit methane, and others do. So you can certainly judge for yourselves whether you're one of those or not. But we have a hindgut fermentation, and it's just the same as the hindgut fermentation in a horse or a cow. We do have bacteria in there that break down what's left in the gut by the time it gets to the hindgut, and one of the end products is methane. But the interesting thing is not all humans emit it, so why is that?